we'll now take a few minutes to instantiate this abstract algorithm we described and see what it looks like in the context of learning decision stumps. Turns out the boosted decision stumps is a really nice, simple default way of training on your data. And so it's one that we'll just go through a little further and help us ground some of the concepts that we looked at so far. So here I've outlined the AdaBoost algorithm that we discussed before in the previous slides. But just to be clear, we're going to talk about learning a decision stump for f of t and figuring out how to update its, figure out its coefficient, w hat t. Our first step is figuring out how to learn the next decision stump. That's going to be f of t. And this is just going to be like standard decision stump learning. We're going to try splitting on each feature, income, credit history, savings, market conditions, and figuring out how good each of the resulting decision stumps are on the weighted data. And notice that in our process, we might split on income multiple times. So in multiple boosting iterations, we might revisit the same feature. So we're going to try each one of those features, and for each one of them, measure the weighted error on the training data. So for, say, splitting on income, the weighted error might be 0.2. For splitting on credit, it might be 0.35. For splitting on savings, it might be 0.3. And finally, if you split on market conditions, it might be the worst of these 4 decision stumps on this weighted data. It might have weighted error of 0.4. So we're picking the best feature, the one that has lowest weighted error, and so we're going to pick that first one to split on. We're going to split on income greater than 100,000. And so f of t is going to be the decision stump that says income is greater than 100,000, if yes, safe, if not, is a risky loan. Now the final question is, what coefficient we give to this particular classifier? So all we have to do is plug 0.2 into the AdaBoost formula, and if we plug it in and do the little math, it's 0.69 is the result. So the coefficient of this first decision stump is just going to be 0.69. Going back to the AdaBoost algorithm, we discussed how we are going to learn a decision stump from data and how we figure out its coefficient. Let's next talk about how to update the weights alpha I of each data point. So here's the intuitive process what happens. We have our data points, and I'm highlighting them here depending on their income, just like we did before. But I'm going to make a prediction using this decision stump. The question is, how good is this decision stump income greater than 100,000? And if you look at it, it makes mistakes in some of the data points and gets other right. So I marked the correct ones in bright green and mistakes in bright red. And if we take the previous weights alpha for each one of these data points, I'm highlighting what those weights were right there. We need to compute the new weights based on the formula above, which is the standard AdaBoost formula. So we're going to plug in the W hat that we computed, 0.69, into the AdaBoost formula to figure out what to multiply each one of these weights by. So if you plug it in, you'll see that each of the minus 0.69 is a half. So for every correct data point, we're going to half its weight, and each of the 0.69 is 2. So for every incorrect data point, we're going to double its weight. So I'm going to go row by row. For the ones in green I got correct, I'm going to half the weight. So for the first row there, the weight before was 0.5, and now it becomes 0.25. The next one was 1.5, it becomes 0.75 because I got it correct. For the third row, I made a mistake. Its weight before was 1.5. Now I'm going to double it. I'm going to make it 3. So we can go data point by data point and either multiply it by 2 or divide it by 2, the weight, depending on whether we got that data point right or not. Extremely simple to build a boosted decision stump classifier, and this tends to do extremely well on a wide range of data sets.